right? So so when you run the code, it will take 2.67 seconds. But now there are special functions that are known as ufunctions, ufuncs, and these come with Numpy. They improve the speed tremendously. So we want to look at this example. Here we are computing our reciprocals, right? Using ufuncs, you can write like this, right? This is how we are timing. We are timing the operation. Then directly we are writing 1.0 divided by big array. You see this will take us 4.71 milliseconds, which is very, very fast compared to the 2.67 seconds, right? That's one advantage that Numpy comes with, right? You can execute these functions, make it or create some new examples for yourselves so that you can actually see the difference, right? This is another example also for calculating these so-called reciprocals, right? And ufunc operations are not limited to one-dimensional arrays. They can act on multi-dimensional arrays as well. For example, here we are developing an array, a 3x3 array, which consists of 9 elements. That is from 0 to 8. This one, 3 rows, 3 columns. So now we are going to use ufuncs. So this is how ufuncs work, right? We want to raise each element in the array. We want to raise it to the power value you added. For example, maybe before we do that, I just want to do this. Sorry, I just want to do this so that you guys can see. Just want to do this so that you guys can see. Modify the code here. We can call this one let's call it S, right? Then we want to print S here, right? If we run it, the original array, it will look like this, right? But when we use this function, we are now saying 2 to the power of each element, right? For example, at position row 0 column 0, we are going to replace this value with 2 to the power of 0, which becomes 1, and replace this one with 2 to the power of 1, which becomes 2. Then replacing this one with 2 to the power of 2, which becomes 4. And you do that over and over again until you get this new value. So this is an example of Numpy ufunctions, and you can also use them in this way. Here we have generated a range of values, which it's a one-dimensional array that we have here, right? Which is 0, 1, 2, 3, 4, right? Then if you use this ufunc, and if you use this ufunc, 5 is going to add it to each and every one of the elements in the array. So 0 becomes 5, 1 becomes 6, 2 becomes 7, 3 becomes 8, and you do the same with -5. You are subtracting 5 from each and every element. You do that on and on. This one you multiply, in this one you are dividing. This one is floor division. You remember floor additivity. If you are getting 3.1, you get 3, and because the commas will be removed, and yeah. Now 5.74. The floor of 5.74 is 5. The floor of 5.1 is 5. The floor of 6 point anything is 6, and the floor of 100 point anything is 100. That is what you should know. Permaflows is, and yeah. You can also do the same for negation. Negation, it simply means you are converting each of the element inside here from a positive number to a negative, or vice versa, and times really, it means to the power x to the power of 2, and so it means 0 to the power of 2, 1 to the power of 2, 2 to the power of 2, 3 to the power of 2. Then modulus, you remember modulus, what's the remainder after you divide, and what's the remainder of 0 if you divide 0 by 0? What's the remainder of if you divide 0 by 2? What the remainder of 1 if you divide by 2? And things like that. So you can go on and on and on and on and on. And you can also use the functions. They also have wrappers. For example, if you want to add a certain number to each and every element within an array, you can just use the function add. Then you write the name of the function, then the number that you want to add, and the number that you want to add.